So this is the next reaction, decomposition reaction. And again, we're predicting, writing balanced chemical equation, complete ionic, net ionic, and also represent the reaction on a micro scale. So our example today is potassium chlorate. Potassium chlorate heated, or chlorate heated. Now one thing you'll need is this blue sheet, and you'll need to be able to look on this side where you're actually looking at some patterns, prediction patterns for decomposition reactions. And we'll take a look at that again in a second. So we're looking at potassium chlorate. Now it doesn't say solution, so you're to assume that this substance, this ionic substance, is in its lattice structure. And so this ionic substance, which is K with chlorate, it has a lot of oxygen, so ClO3, and it's a solid. And this ionic substance is being heated. So I'm going to add heat. And remember, the heat can be added using a triangle or the triangle with H. So the arrow is going to go to the formation of the products. Now, how do I know what substances will form as a result? Well, chlorates tend to expel oxygen. So if you can pull oxygen out, you will form an ionic compound and oxygen. So if you're having trouble with that, you can also see it right here. Chlorates right here, any compound with chlorates will expel oxygen gas and the metal chloride. Okay, so this is a general pattern for prediction. So here's your oxygen, or here's my metal chloride, state of matter, and then here's my oxygen. Again, state of matter, because we need to know whether the physical states are driving forces. So now I go to the next. The next one is to look at the substances. Now, since we're not in solution, our ionic compounds, we can't look at our solubility table for our ionic compound because we're not in water. So we're really going to have to use our knowledge of ionic compounds and the states of matter of our ionic compounds. Since they take on that strong lattice structure where it has those opposite charge ions, ionic compounds are solids at room temperature. Oxygen gas is a gas at room temperature. So let's balance this reaction out. In balancing it out, you'll see that you need, now I'm looking at these the oxygens, and I'm seeing that potassium and chloride are balanced, but the oxygens aren't. And I notice the two numbers being 2 and 3. So I have to use common multiple to figure out a common multiple to balance these equations, the oxygens out. And the common multiple between 3 and 2 is 6. So I'm going to multiply this by 2 to get 6 oxygens, and I'm going to multiply this by 3. So I'm going to get 6 oxygens through that. And so here you have a balance equation, not until you put the K2 coefficient in front of the KCl. Now you have the balance equation ready. So again, complete ionic, and net ionic is just as easy as it is in decomp, in the sense that you're not in solution in those in the example problem or the examples in the other reaction. And so you're not to separate them into or dissociate the substances into ions. So because it's a solid, we keep it as KClO3 plus heat forming. Now let's look at these two products, and we're noticing it's a solid, so 2KCl. We're noticing this is a gas, so we keep it as 3O2. So let's talk about driving force really quick. I didn't need to put the state of matter, but let's talk about driving force. Gases are a evidence of a driving force, and as well as the formation of a solid. So here's another solid forming as a result, indicating that this is a driving force. So net ionic equation, again, nothing that you can dissociate, or nothing that cancels out because you didn't dissociate anything. So you're going to maintain to leave the same reaction for the net as you do for the complete ionic as you did for the balanced chemical equation. So this is a solid, heat, solid, potassium chloride, solid, and then oxygen gas as your gas. Again, these two are driving forces, both driving forces, or evidence. Another way of saying driving forces is these are evidences of a chemical change or a chemical reaction. So now we get to our reactants. I'm going to get rid of this. Why am I going to get rid of this? Because I have only one reactant. It's potassium chlorate. So I started off with potassium chlorate, which is chlorate, and I have two of them. So I'm going to represent KClO3, and then I'm also going to represent another KClO3 on the bottom because it's a solid. And I'm going to represent heat, delta H or delta, into this reaction. So again, I'm looking at the complete to see what I include. Now in this reaction, I'm also going to now see a solid KCl, two of them. So KCl right here, and then another KCl in this lattice structure. So it's a solid. And then I'm also going to see 3 oxygen molecules. So one oxygen here, another oxygen here, and O2. And it's trapped in the container, so you're seeing those gas particles, gas molecules float up on top of the solid. Okay, that ends this reaction.